exactly same. Am I right? The true value of a component is 100 mm and you are measuring. You are also saying 100 mm. Now, what is the difference? What is the difference?
No difference.
Bias is 0. Bias is 0. Whenever bias is 0, you are accurate. You're fully accurate, right? So, bias is preferred or not preferred? Not preferred, right? Bias, nobody likes to have the bias, right? Suppose you want me to measure a component which is 100 mm. I am measuring it 10 times. Now, how will you calculate bias? Dr. Ravi has taught you. When you have same reading, when you have same part measured repeatedly 10 times, then calculate the average. Find out the difference of the average and from the true value. The difference between the average of your reading and the true value is called what? Bias.
Bias.
So what is our goal? Bias should be 0.
0.
If bias is not 0, what will you do? Bias is not.
We will check it is linear or not.
No, that is next point.
So it is kind of a deviation also.
Yeah, it's a kind of deviation. It is called a bias. If bias is there, how will you eliminate the bias? We calibrate the equipment, right? We calibrate the equipment. Suppose my watch is running 10 minutes fast. So bias is 10 minutes. My watch is 10 minutes fast. So the bias is positive or negative? Positive bias. When the time is 2 o'clock, it tells 2:10. So bias is positive. Now, how will I correct? I will adjust the timing, isn't it? I will adjust the timing and what we call it calibration. Same way, in your equipment, whenever you have a bias, the solution is calibration. That is why all of you are calibrating your measuring gauges. Are you doing it in your company?
Yes.
Yes. Right. Yeah. Very good. And then another thing Dr. Ravi spoke, stability. What is stability? When I use my gauge, in today, it gives me a bias. When I use the gauge tomorrow, again it will give me bias, isn't it? When I use it next week, again it will give me some bias. When I use it next month, again it will give me some bias. Do you want the bias to be same, or bias can continuously increase or continuously decrease, or can it vary randomly? What is preferred? First of all, bias should be 0. Suppose if there is a bias, it should be stable. It should be stable. Whether my bias today and bias tomorrow, bias next week, bias next month should be same. If it is not happening, how will you sort it out? You need to increase the
calibrate.
Increase the frequency of calibration. Increase the frequency of calibration. For example, how do you know how frequently you calibrate your gauges? Once in a year or once in 6 months?
Once in a year.
Okay, once in a year. And suppose I'm doing a project for 6 months. First month I used a gauge to collect the data. Then after 3 months, I use the same gauge. Now its bias increased. What will happen to your reading? You might think that no, you have solved the problem, but the gauge bias has increased within 3 months of time, because 3 months people used, somebody could have dropped it, isn't it? Somebody could have mishandled it. As a result, what will happen? The bias might increase. So at the start of the project, you had some bias, but during the project, the bias increased. Towards the end of the project, the bias is further increased. Is it a healthy scenario?
No.
So bias should be stable. If you have problem in maintaining the same bias or the stability of the bias, then you have to increase the frequency of calibration. Don't just do it once in a year. Maybe. See, I want all of you to be very attentive today. If you are not interested, you can leave the meeting. I have already told you yesterday many a times. making you learn tough modules in an online mode is really tough for the trainers. You have to cooperate. You have to understand our requirement also. You can't do, you can't do two work at a time. You have to be here the 4 hours, and then only we can do something what we have planned. Very oftenly it is happening. Keep your background noise free and see that you are focused here. Otherwise, what happened? We cannot understand whether you understand a simple concept or not. Bias is a very simple concept. If you measure wrongly, then there is a bias, right? So bias can be positive, bias can be negative, bias can keep on increasing, bias can keep on decreasing, or bias can be constant. If bias is constant, we call it stable. Then if the bias is constant, calibrating once in a year is enough. Because once you calibrate, yes, it is constant and it is safe. At least during the project period, you can trust the equipment. But if the bias is not constant, then it is a stability issue. Then the solution for it is increase the frequency of calibration. And to understand the stability, you can plot some readings using your gauge in a control chart so that you will understand the stability part of it. He also spoke about one more thing, linearity. What is linearity? I measure this, I use the same gauge for measuring 10 mm also, for measuring 100 mm also. I use the same ammeter for measuring 10 ampere also, measuring 100 ampere also. Can I use the same ammeter for measuring 10 amperes as well as for measuring 100 ampere? Sometimes it may,
Yes.
sometimes, it may not be a wise decision. Your gauge may work accurately with the higher values, but may work inaccurately with the lower values. Am I right? For example, the normal physical balance. Normal physical balance, you can use. And in the jewelry shop, they will have a physical balance, isn't it? Right? The normal physical balance, I can use it for measuring in kilograms. But in a jewelry shop, where I want the accuracy to be in milligrams, isn't it? So can I use the same physical balance for the measurement in milligrams as well as measurement in kilograms?
No.
Not possible. So at that point of time, you have to divide your range of measurement into some interval, maybe some 5 category. Then for each category, you will have a gauge. That will solve your linearity issue. Otherwise, what will happen? Your bias will vary depending on the range of the reading. So bias over time is stability. Bias over range of reading is linearity. You must overcome both, right? And then only your reading will be accurate. Okay, so with that, let me share my screen and then we'll move ahead.